All right, so that donut with sprinkles cost me about 3 hours of my time. I had a lot of little moving parts. I chose to do the metropolis algorithm on the torus and then try to fit it into the simplicial complex. But as you can see, if you look at the U shape, it does seem to have kept the middle of the donut at least, but I cut it in half because I wanted to see if it would keep the inside. It was a little harder to tell. We'll see if we can kind of zoom in here, and I believe it is. I think it is preserving the structure, or maybe the topology, as we say. Like it does look like it is. The brighter dots are closer, obviously, and then the dimmer dots there are back behind. It doesn't seem like there's any, or at least there's not a lot of lines crossing here. And I think that's nice. I think that's awesome. I do think it's working. I am worried about how busy it is, and this is a very low distance threshold, so I still may have some work to do to fix that, but at least the topology is being preserved, so that's really nice. Okay, so let's look at the code real quick. I just want to kind of go over my steps of what I did. And as you can see here, here's the 16 rings. It gave me like about 256 points. Of course I did cut that in half, but this is basically the, I don't know, more pure version, I guess you would say, of the torus that I used. And then I did this metropolis algorithm. I generalized it at first because the torus was coming out with 2 by 2 matrices, and I thought, okay, well, I have to get 2 by 2 and might as well generalize it to 3 by 3. And for some reason, I was thinking 3 by 3, so then you see this is a normal distribution of points three-dimensionally. At least it seems so. As I could have used a histogram to kind of show this stuff too, but I mean, that works just as well. You could see that it gets denser towards the middle. And that's all I kind of am looking for. But I did some weird things, and I was playing with it because at first the metropolis algorithm was giving me a one-dimensional array, and for X, Y, and Z coordinates for this torus, it was giving me two-dimensional or three-dimensional arrays. I think it was two-dimensional, so two by two matrices. And, or no, it was 3 by 3 matrices, but it was, I don't know. It's so confusing. It just got me all wrapped up, and I think it's because of NumPy mesh grid. I had to go to ChatGPT to try to figure out what the NumPy mesh grid kind of was doing. And then I realized that you can actually, when you actually go to display it flattens it out in the scatter 3D anyway. So in this scatter 3D, it just flattens each one of them out. So I decided, oh, why not just have them flat? It must be able to be flat. So once I did that, even though I had this generalized metropolis algorithm, I was able to just, I don't know, they didn't link up perfectly, but it works. So that's all that matters right now, I guess. And so I added noise. And once I finally added the noise correctly, actually, I added the noise wrong. In my last video, of course, I added the noise wrong, and it just kind of skewed the rings. It made the rings tilted or jostled the rings in different positions, but kept that general structure, which was interesting. And I actually did it with 3. I actually did the metropolis algorithm in 3 dimensions at first before I tried the 2 dimensions to link it up with the 2 dimensions that were coming out of the torus. And when I did the 3, it actually, every point got a random distribution of points around it. It was so trippy. It was just weird. I mean, I could have used that data probably, but it was just so interesting, like how it did different things depending on what the metropolis algorithm outputted. Anyway, I was able to nudge these in each kind of in a random direction with a normal distribution. So I think that worked out pretty well. And that's about all I did. I then was able to use the torus plus the, I was basically able to use the torus plus the noise, so, and just feed these right into that function that I made for the simplicial complex. And it seems to have preserved everything. I'm still a little worried that there's something that I'm overlooking, so I'm gonna dig deeper, and I think it's about time for sliders. I think I'm gonna bring some sliders out and see if we can see what's going on a little bit better. All right, thank you for watching.